blows his whistle. Sorry, this is June 06 paper 2 question 3. John blows his whistle. A short time later, he hears the sound of whistle again, though it is much fainter this time. In front of him there is a long, high wall. Explain fully how the sound of the whistle is heard twice. Now there's 4 marks going here. I don't know if you can see that or not. 4 marks. So that is really, you're going to have to try and get 4 sentences here, which will pick you up your 4 marks. So first of all, 1 mark. Why does he hear it first of all? So he hears it directly when he blows it. I'm going to say as soon as he blows it. And there's your first mark. Now 3 more to get. So what happens after that? Well, you know that it travels to the wall, it reflects back, comes back to him as an echo, and that's when he hears it again. So the sound travels to the wall, is reflected back, as an echo. And those are your other 3 marks: travelling to the wall, being reflected, and the echo idea. And then there's a calculation on this. So using a stopwatch, John measures the time interval between blowing the whistle and hearing the whistle a second time. The stop clock records a time of 0.8 seconds. Then he measures the distance to the wall and finds it to be 138 metres. So you already know the distance is 138 metres. And the time is 0.8 seconds. Now that time is, of course, as with most of these echo questions, that's the echo time. And so to get the actual time we're going to use in the calculation, you have to divide that by 2. That gives you 0.4 seconds. So speed is distance over time. Again, we should know the answer we're thinking about getting. Speed of sound in air, we know, should be approximately 340 metres per second or thereabouts. So I'm just putting a question mark there. You're not obviously going to write that in, but we're thinking about an answer like that. So distance is 138. The time is 0.4 seconds. And the answer that we get out is actually 345, which we're going to put in here. So there's 1 mark for your answer, 1 mark for the 2 numbers in your calculation, and 1 mark for distance over time. Now if you didn't divide your time by 2, you'd only end up with 1 mark there. But at least if you write your equation down, you will have 1 mark. As a wave passes through a certain medium, the particles vibrate through a distance of 5 centimetres parallel to the direction of the wave, as shown in the diagram. In the diagram, the particle X vibrates through a distance of 5 centimetres, so from A to B is 5. What kind of wave is this? So you can see the particles vibrating in this direction and the waves travelling in this direction. Those are parallel, so it must be a longitudinal wave. Now they will let you away with saying sound there, or even ultrasound. That would be a suitable enough answer there. Next question, what is the amplitude of the wave? So you can see that the total displacement of the wave about its rest position is from A to B, and you're told that that distance there is 5 centimetres. Now you know the rest positions here, and amplitude is measured from the rest position to the top of a crest or the bottom of a trough, or in this case to the maximum displacement on one side. So it's going to be half of 5 centimetres, and the answer is going to be 2.5 centimetres. The time for 1 complete vibration of the particles of the medium is half a second. So this is the 3rd time this kind of question's come up again. What is frequency again? Frequency is the number of waves in 1 second. Okay, or the number in this case of vibrations in 1 second. And so to calculate frequency, we're going to take the time for 1 vibration, the number of waves in 1 second, so we have to divide by 0.5 seconds to find out how many waves you'll get in 1. Now it's really tempting to divide 1 by a half and get a half. It's so tempting, but there are 2 halves in 1, so the answer there is 2 hertz, not 1. And if you weren't sure you got the right answer, read through that again. It says the time taken for one complete vibration of the particles is half a second. So in one whole second, you're going to have 2 of those. That should make sense to you. Okay, so there's 1 mark for that. 1 mark for writing that down. Actually, it's not for writing that. For writing 1 wave in half a second. And then your 3rd mark is for your calculation there. The wavelength of the wave is 50 centimetres. Calculate the speed of the wave. You're advised to show clearly how you get your answer. And if you look carefully there, you can see you've got an answer in centimetres per second. So you can get away with leaving your wavelength in centimetres. So we'll write all the things down that we have. Wavelength is 50 centimetres. Frequency is 2 Hertz. And speed in this case, because we've got a wavelength and a frequency, we're going to use V is equal to lambda F. And so that's 50 times 2. And that gives you 100. So the answer there is 100. So 1 mark for the 100, 1 mark for the 50 by 2, and 1 mark for the V is equal to lambda F.